This is video 4 for section 2.4. I'm going to start this one with this problem. First thing I need to do is rewrite this as x to the negative first plus cosine x to the 1/2 power. I'm now ready to take the derivative, and when I take the derivative, I end up getting negative x, lower that by 1, so it's negative x to the negative second, plus, bring out your 1/2 out front, rewrite what's on the inside of the parentheses, and lower it by 1. Since this isn't just an x on the inside, you have to take the derivative of what's on the inside, which is negative sine x. Let's clean this up just a little bit. This ends up being negative 1 over x squared plus, I have 2 on the bottom and the cosine of x on the bottom, and I have negative sine x on the top. I am supposed to evaluate this at pi over 2. Now, because I know a little bit about what I'm doing, I want to always check to see if the bottom is going to be undefined or if it exists. And in this particular problem, it doesn't even matter what I do or what the other things equal, because the bottom of this fraction is equal to 0. Therefore, the derivative at pi over 2 is actually undefined. Again, that's because you get 0 on the bottom of this fraction right here. Moving on, we're going to end up doing another derivative. I've done lots of different examples today. So I've got tangent of x squared. This one's a little bit easier to take the derivative of. We're just going to bring this 2 out front, rewrite what's on the inside, lower it by 1, and take the derivative of the tangent of x, which is secant squared x. We will be evaluating this at pi over 4. So I will plug in pi over 4. I need to know what the tangent of pi over 4 is. I know that is 1. Secant pi over 4, most of us are probably going to think about that a little bit more. The secant of pi over 4 is really saying what is the 1 over cosine of pi over 4. Well, I know the cosine to be square root of 2 over 2. So that means that it's really 2 over the square root of 2. So I will be multiplying this by 2 over the square root of 2, and that will be squared. So my final answer will end up being 2 times, that would be 4 over 2. So it'll end up being just plain old 4. My last example asked me to find the second derivative. So I need to find the first derivative. And in order to do that, I will rewrite it. Ready to take the first derivative, I'll bring the negative 1 out front, rewrite what's on the inside and lower it by 1, and take the derivative of what's on the inside, which is a 1. So the first derivative ends up being just negative 1 over x minus 6 squared. Now I do want to take the second derivative, but in order to do that, I have to know what the first derivative is, so I'm going to actually go backwards and rewrite this as negative x minus 6 to the negative second power. So now I'll be able to take that second derivative, using the notation double prime, bring this out front, 2, rewrite what's on the inside, and lower it by 1, take the derivative of what's on the inside again, which is a 1. We end up just getting then 2 over x minus 6 to the third power, and that is my second derivative.